think, folks, we're going to go ahead and get started. Hi, everyone. Thank you all for attending the talk today. My name is Corey Dobson. I'm a solution engineering lead here at Poolside. Today, I'm going to be joined by Ivo, principal from our solutions architecture team, and Praveen, a senior engineer from Northrop Grumman Space Systems, an organization who actually deployed Poolside securely in their organization. I want to thank AWS for the opportunity to speak today, and for you all wrapping up the final day of the conference, spending the afternoon with us. It's really been great. As this session is titled Poolside AI Models for Highly Secure Software Environments, we want to present today a high-level overview of our product stack and how it's unique for software teams, either in those highly controlled or air-gapped scenarios, and kind of an overview of our deployment structure, what that looks like on AWS as well. Poolside's models are built for various types of users. However, software is really a bread and butter kind of use case for us. So we're going to also show some demos of this stack working within the SDLC and hear how software folks like Praveen at Northrop are using Poolside today. If you like what you hear in the presentation, we do have a booth in the expo hall. I know the expo is closing soon, but it's booth number 802. It's right, big parasol booth when you walk in. So some folks are head nodding. You might have visited the booth and grabbed some Poolside swag throughout the week, but maybe after this session, hop over there and come and visit us, especially if you think Poolside might be able to help out your organization, your software teams. So let's get started. What is Poolside? Well, Poolside is a frontier model lab building secure enterprise AI systems deployed anywhere. We're a US-based company. We're founded in 2023, and we build both AI models and the agent orchestration platform that powers them completely from scratch, designed to run entirely within your own infrastructure. AI has definitely reshaped how even the most secure mission-critical work gets done, and our aim at Poolside is to be that mission-critical platform. We power teams with our complete AI infrastructure stack and some expert research engineers to help design their AI workloads. We've read about far too many POCs that never make it into the production stage. They stay AI POCs, either due to some data that needs to stay within the network that unfortunately has to keep getting passed out, or teams just not being able to confidently deploy AI agents at scale within their infrastructure. So we solve this with both the software stack and research experts to embed with your team. So let's dig into that software stack to start and learn about what we mean when we say complete AI infrastructure. To start, it begins with the Poolside foundational models. Poolside models are trained with internet scale data, and they're combined with some proprietary synthetic data sets we have. Our colleague at Poolside, Joe Roll, did an excellent job earlier today breaking this down in a previous talk. So if you're interested in how we actually do pre-training and post-training of these AI models and what we call our model factory, our model building process, I'd recommend checking out the recording of that talk or checking out our blog series on our website page called The Model Factory. It's quite a deep dive into this virtualization environment, but it's what we scaled for our applied research team to be able to scale up model checkpoints and be able to essentially build this piece here of our stack. It's worth noting that this Poolside model piece is not based on an open source model. It's not just, say it's an open source model and then fine-tuned, but rather our model that we run pre-training and post-training on. And we have some novel techniques built around reinforcement learning, which allow us to create some high-quality synthetic data sets for future model training too. So Poolside doesn't require, nor do we want any of your data for model training. When you use Poolside, no data comes back to us to train the model. That's a core philosophy of us. It's truly your own model that you have on-prem. When you deploy Poolside, you get the model and all of the weights. So it's really the complete stack here, and it starts with the models. It leads us to the next piece, which is connecting it to your organization's data and making it relevant for your team. Since Poolside's deployed entirely in your boundary, it can be connected to any data source securely, because essentially we come to where the data is. We don't ask your data to come to us, but rather we bring the stack to you. And this allows Poolside to securely access context from knowledge bases or runtimes, data sources that you normally wouldn't want to pass outside of your network. Well, you can pass those securely to Poolside without compromising any of your intellectual property. So unlike maybe other AI models that send your data outside of the network or into some sort of data moat, Poolside brings this stack to you. We then meet developers and teams, wherever they are to access those models. So they can be accessed through a multitude of different IDEs. We talked about software engineering use cases. We're going to see these in just a minute, as well as through a terminal CLI, in coding agents for software engineers. But Poolside's built for the whole organization. So although we'll call out products like our API and our IDE, and even non-developers will use Poolside through our agent orchestration platform. And I'll show a little bit of that here in a demo. But the takeaway here is that we build really the back-end model structure and the front-end interface for your team. So when you have Poolside, you have, in this case, the model infrastructure and all the product interfaces. This all, again, gets deployed in your secured network. Now, Poolside's really, truly isolated AI for your organization. And this enables us to work with even the most highly regulated financial services companies, public sector companies. They can leverage frontier AI tools without, in this case, the risk of data egress or some sort of data leaving the network. It's a stack that they can deploy for their entire organization. And we can design this whole stack to where maybe it's a single deployment of Poolside or multiple deployments of Poolside for various different programs. So even the most mission critical work can leverage a secure AI platform. And over time, this stack becomes an AI software foundation for you to build on, because it's all within your control. Again, you have the model weights, you have all the product interfaces, it all is customized for your security boundary, and we don't have the risk of data egress, losing core IP for your business. So we don't require or want any of your data to make this stack better. We give it to you and let you customize it. We have two models available today in our stack. Malibu Agent is our agentic model. Point is our auto-completion model for code. And they can be deployed entirely within your organization's AWS account, either in a AWS VPC or Amazon Bedrock. We also contract entirely through your existing AWS agreement. So we have a fairly rare Tier 1 agreement with AWS, allowing customers to use their existing AWS agreement and committed spend to use Poolside. So I'm going to pass it over to Ivo, and I want to dig in here for a few minutes on how to deploy Poolside within an AWS account.
Yes. Thank you. Not the mic. Cool. So I think we saw a lot of slides that didn't show any AWS thingies, right? And you're all in AWS conference, so I want to get you started on what we actually deploy in your environment, right? As Corey said, this is completely within your account. We don't have any SaaS offering right now, so we actually deploy this with you. We help you deploy in your specific account. Starting from the bottom, I would like to walk you through the diagram. So it's a very simple architecture, as you can see. We have like a database, Postgres, it's an RDS. And then we can have the brains of the operation, which is our EKS cluster. EKS cluster is where things start to get interesting, right? So you'll see two node groups there. One is grayed out because it's optional. So our mandatory node group is like a CPO node group. This is actually where our API runs, web assistance, which is basically like a UI, right? And then you have optional node group, which is GPUs, in this case P5s. And it's optional because you can also deploy on Bedrock. And by deploy, I mean you can use it, right? You either choose to use your own GPUs, and we give you the wage for that, or you run on Bedrock, and you just call the API from the CPU node groups. You see like a bunch of auxiliary services here too, right? You see S3, you see CR. And the reason for that is because like we have to host our things somewhere. To access it, very simple. You just access it through a load balancer. You see it is in a public subnet. So, it couldn't be a simpler architecture. But some of our customers, as you'll see with NGC and others, are very secure-focused. Security is a tier 1 construct for AWS as well. And they told us we cannot have internet access at all. So they cannot have an IGW on their VPC. And for us, it's fine. We support that too. If you look at this architecture, we basically replaced the whole public subnet with a private one. And we created a bunch of VPC endpoints. For those not familiar with VPC endpoints, they're just a way for you to access AWS services without going through the internet. So we still need, obviously, access to AWS services, and this is how we achieve it. You also see that now the ALB became a private ALB. You need to access this somehow. We just changed it to a private one. Another security aspect from this architecture, you'll see I put some keys around all the components, is that some customers can also not use AWS managed keys. They're very useful to get started, but not all customers can access those. So they need to bring their own. This is very common with security customers. And you see we support you to bring your own keys. So from EKS secrets, on the EBS nodes, on the database, so on and so forth. But when you look at this diagram, if you are, a little bit networking focused, you'll see, okay, but how do I access this? Like there's an ID extension, there's other components like how am I going to query this API if this is an isolated VPC and everything is public. And this is where the rest of the stack comes in, right? So we are not picky. We support all types of access. For example, site-to-site VPN from your on-prem, maybe client VPN from your employees' computers, direct connect, you name it. Like it doesn't matter for us. We help you deploy this and make sure it works. So we kind of guide you through the deployment. And you also see that I added a network firewall there. And the reason I did is because we also support inspection architectures. For this specific slide, I put it as a centralized firewall. We leave this on VPC, you go to transit gateway and you are inspected. We also support other architecture, like for example, distributed inspection. So this is kind of like our architecture, as you can see. Very simple, you'll be able to access it from everywhere. But for those of you that have been using AWS for more years, you know that not all regions are created equally, right? So could be from service availability to simply parts of the service availability. Maybe sometimes the API is not available equally everywhere, and this is not very fun to find after the fact. So we do support many regions. We kind of go with you, and we basically check the region you want to deploy to. But even within the regions, some are different, and they call it partitions. For those not familiar, in AWS partition is something completely isolated that has regions inside, and they're only communicated through the internet. So for example, you cannot use an access key to communicate them, right? Or any sort of TGW, this doesn't work. We also support different partitions. You'll see here the commercial one, Golf Cloud, and we also support some that are not in the slide, like the secret region and the top secret region. Again, I want to emphasize that we do help you deploy this on these partitions, right? And we kind of guide you all the way. I think you guys now are a little bit familiar with how we deploy. It's not super complex architecture. I want to also guide you through our customer approach, right? If you deal with AWS, you know that customer obsession is very important for them. It's a leadership principle. They talk about it on all the conferences. And I was AWS, so I'm very familiar with it. At Poolside, we kind of embrace it too, right? So customers for us are very, very important, and we wanted to do right by them. And we cannot just install something and give them the keys and just leave. The reason is that most AI POCs right now are failing, right? I think there's a statistic from MIT that says like something like 95%, I think it is, don't reach production, right? So if I just give you the access to our model, no matter how good our model is, no matter how good our agents are, most likely you have like a 5% chance to make this successful, right? And that's why we at Poolside guide you all the way to until you reach production. Our SAs and SEs help you become what we like to call an agentic organization. What does this mean? It's not just a keyword, I promise. We help you achieve your use cases by creating new agents, maybe doing like some prompt engineering, but actually what we try to own with you are the actual business outcomes. We do this in a more, I would say, consultative approach, and it's been working out for us, but some specific customers needed even more than that. They needed like a boots on the ground, hands on the keyboard approach, and that's why we created a 4 deployed research engineering motion. What are these guys? Well, they are applied research engineers, right? So they are not some typical LinkedIn influencer that says KV Cash and gets a bunch of likes, okay? So they are really people with experience taking POCs to production in AI, okay? And they help you as an extension of your team. So they will work within your teams, within your engineering, product teams, and they will help you achieve your use cases. This could be, creating a new pipeline, maybe creating a new agent, or maybe just scaling this to thousands of users. They are an extension of your team, really. And by now I see your faces, so if you forget everything I said so far, what I want you to take from this talk, okay, is that Poolside is not just about tokens, okay? It's about business outcomes. We are an enterprise-focused organization, and we help you have a shared responsibility model with us, owning those outcomes. So I don't just hand you the keys to the model and say, have fun, but we actually help you get the best out of that. I'm in engineering, as Corey said, I'm a principal engineer, and I'm not about just talk. So I want to show you real demos, and for that, I'll call Corey, that is going to show how all of this actually works.
Yeah, thank you so much, Ivo. Yeah, so let's dig into some of the use case demos and this stack in action with a software focus running with enterprise code. The first demo here is a clear case that we were able to help software teams with, especially teams that work in legacy systems and/or closed environments. In this demo, we're going to show how the Poolside ID extension and model converts a non-trivial Ada code database project into Rust. What you'll see in the demo, I'll play it in just a sec, is the ID extension walking through this code base, understanding its structure, using tools, and then rewriting that structure. If anyone, I see a few head nods, are unfamiliar with Ada code. I was before I started working with a few different customers who use it. Ada code is a legacy language. It was originally released in the early 80s. It was developed by the U.S. Department of Defense, and it's still used in many mission-critical applications in aerospace and aeronautics. So let's get started and see this in action. So I'll do my best to pause and narrate here. What you're seeing is kind of the initial prompt to rewrite this code base, and you'll already see on the left-hand side there in the chat, or yeah, your right-hand side there in the chat is the ability for the agent and the model to start using tools, right? So we're reading and grepping through the code base. This is all Poolside. It's important to note that this is the Poolside model, the Poolside agent. We are using an open source IDE as our client here. However, the ID extension is also built by us. So the interfaces are all Poolside, and the backend model is all Poolside. What you'll notice here as I play this is that the inner monologue of the model also creates this to-do list, and it breaks this down much like how a senior software engineer would want to break this down. We're rewriting a database, right? So we need to think about the table structure, the record structure, then we need to rewrite the query parser. Each one of these steps is potentially a new file, potentially editing an existing file in the call chain, and the agent is kind of traversing here. You also see it start to use different shell commands to actually test its work as we get along. Rewriting its implementation as it maybe finds errors in its own code. And at the end of this demo, we'll see that we can actually go into the shell here after we have a nice output of what it completed, and then test out some database commands. And it's now Ada code to Rust style database. So a single agent in the Poolside stack running inside the IDE. Keep that in mind. We're in kind of this single agent process right now. In the next demo, we're going to work with a multi-agent scenario. But in this case, we're going to work in a headless fashion. So imagine we're in a financial services use case. We have a kind of demo stock trading app here showing that we might want to traverse multiple issues that are going wrong in our program. We're actually going to be using the API and the agent runtime here with the model, but outside of the IDE. So in this case, we're going to be having this AI-enabled SDLC, and the agent model and interfaces are going to be completing units of work without necessarily the developer having to pull down the code and initiate that unit of work. So I'll go ahead and play that and narrate along the way. So what you'll see is that we're using GitHub issues here, just GitHub natives, to track issues with the project. And I'm going to go ahead and pause that, because what we ended up doing is adding a certain label to a GitHub issue. Now, this label, called the Poolside agent label, is going to fire off a Poolside agent runtime that's then going to traverse into GitHub Actions and fire off a workflow. There's a lot there, but if you were using, say, Jira for project management and Jenkins for your CI/CD, this exact flow could be replicated. We're the primitives here, in this case, the agent runtime and the model. However, we're just using some pre-built tools to be able to show off a workflow where we're going to send off, I believe, 3 or 4 agents all at once to traverse 3 or 4 issues all at once. So let me go ahead and play that again, and we can walk through. So we're adding the label to the issues. Then we're going to see the GitHub action workflows start to fire off as well. So you'll see that we have now, okay, three workflows, in this case, working simultaneously as 3 kind of parallel agents, all traversing different units of work, creating the to-do list, much like we saw in the IDE demo, and at the end of the day, creating 3 pull requests that we can then review. So this is a truly like headless AI-enabled SDLC motion where the code that you're seeing there in that pull request was generated by the model, but it was generated by the agent runtime that actually just ran in the GitHub Actions container. full automation that we could lift and shift, say, different project management or different CI/CD tools to be able to implement in, say, your organization's very secure network. So the first demo was single agent running in the IDE. The second demo here, parallel agents running in a virtual machine in this case. And the third demo is our agent orchestration pipeline. So in this demo, we're going to have multiple agents chained together as a longer pipeline. And this pipeline is going to do some service investigation into an EKS cluster that something is going wrong. Imagine a new ticket comes through and where you need to diagnose kind of an infrastructure service issue. In this case, a user can't see their orders for their account. Maybe that's a potential workflow. But instead of manually traversing and trying to figure out, okay, which one of the order services or authentication services or various services inside of this EKS cluster are going wrong, we're going to start an agentic pipeline and fire off a multi-agent workflow, chaining the output of one agent to the next in this agent orchestration platform. Again, all Poolside here. So the Poolside agent runtime, the Poolside model, the Poolside workflow, getting to the point where we can generate a report and say, with in this case, a high likelihood, it's actually this particular service that we need to go and check out. So let's play that and see that in action. So this is, in this case, the single agent workflow, and it's going to jump in and be able to discover the different services that we have and traverse this longer pipeline. You'll see as well that all of the agent trajectories and essentially all the agent runs, we also can audit here because we are both the back-end model and the front-end agent runtime. Full traceability up and down the stack is available with Poolside. If you're out there in the expo, you may see that there's companies that are built purely around agent tracking, agent trajectories, but Poolside, we're able to do this because we're the full stack, right? So you kind of have, in this case, a full stack solution to be able to build these longer pipelines and do it securely with data sources that you may not necessarily, in this case, add to an AI pipeline without something like Poolside. And there's the end is kind of our nice report that says, hey, this is what we need to traverse and figure out kind of where we need to go to figure out this issue. So Poolside sees a future where every enterprise is going to want hundreds, if not thousands, of agents, either in that single agent flow or multiple agent pipelines using various data sources. And from our perspective, when we try to play this out 18, 24 months from now, it makes it even more crucial that organizations, especially those in high consequence, high secure environments and organizations, own their stack, secure their infrastructure around their AI platform, not letting the data leave the network. On Poolside, we really aim to be that solution. And we're proud that we've been able to be that solution for a variety of high consequence organizations like NGC. So I'm going to pass it over to Praveen to hear on their journey with Poolside.
Thanks, Corey. So Northrop Grumman Space manages mission-critical systems, and this is from satellite constellation operations to multitude of other on-orbit services. And these are assets, not only high-value assets, but also require really secure and hardened systems, all the way from the algorithmic developments to deployments, testing, and the entire pipeline. So we have been focused on ensuring that the architecture from the beginning is secure and stays secure as we bring in new tools and use these tools for development purposes. So that's where the primary reliance on a hardened cloud like AWS is pretty important for us. And the fact that Poolside, we are able to completely integrate that and also maintain the air-gapped system without any access to external systems. That is very key for us. And also, it allows full control from the end-to-end debugging, testing, code development, and all the way to full loop validation of the systems that we really integrate with other data systems that are private. And that makes for the case that in addition to the other options that we had, it was very important to ensure that the models that we use to request and serve endpoints are not outside of the systems that we control. So that was another key important aspect for us. And in terms of the existing hardened configuration, including the STIGs standards and guidelines that exist in our existing systems, whenever there's a new tool, we need to ensure that that is also taken care all the way from the OS application layer to the network ingress egress. And the fact that the compliance can be maintained was another key important factor for us. And this goes with FIPS 140 in terms of ensuring any cryptographic applications are also FIPS compliant. And that's one of the key aspects. And I'll walk through some of the use cases we have been exploring with Poolside, which stresses on the importance of having the sovereignty over like the data and also the IP that a company like us would kind of use. And so on the documentation side, it is very typical for us or in our use cases to enrich existing code bases with more documentation, not just within the code, but also pulling data from other systems, like where we define tasks and system-level descriptions. But being confident that we can pull in those into the context of the agents and the models while ensuring that we don't send data to a remote endpoint across the network is pretty base minimum level requirement from our side. And so we've been happy with that capability, that we are able to use internal data because we know that the model is being served on the closed air-gapped environment. And with that, not only the documentation is much more enhanced with code-level details, but also with system-level details that it then reinforces the context that are more important and relevant for the systems that are being developed. And likewise, same goes for the test generation pipeline. Previously, you had to depend on unit-level tests that are very siloed, given a code context, but the fact that we can now extend it to internal end-to-end test, but also require system-level understanding is a key enablement for us. And also, like one of the examples we saw from the code, code refactoring agents with ADA's full port over. So there are systems, not just legacy for legacy purposes, but they are really hot-end and tested well for really spacecraft-grade requirements. And the fact that now we can leverage these advanced agents to be able to port over with like the same levels of reliability has been a key enabler. So with that, I'll pass it back to Corey.
Yeah, thank you so much, Praveen. And just to wrap us up here, Poolside, as we learned in that first section, we're Frontier Model Lab building secure enterprise AI systems that can be deployed anywhere. We build these AI models in the AI orchestration platform. This is all from scratch that is designed to run entirely within your own infrastructure, even in an air-gapped scenario. As an organization, with Poolside, you have an isolated AI stack that you can build on for the future. And you'll receive the latest model updates as we publish them. We are a frontier lab. We're continually doing more and more model training, building better and better, more capable models. As we have those, you will get them, but not risk the data egress or losing core IP of your business. And as Eva pointed out, we have a customer approach built around, if needed, forward deployed research engineers that we can power this software stack with. Our forward deployed research engineers embed with your team and help you solve even the most mission critical, complex challenges with agents. Give us the most complex, hardest problem to solve is this agent orchestration pipeline. All this, again, is behind your firewall, so it's this mix of software and teams and people and research engineers to help your organization, regardless of where that organization, in this case, for this talk, develops software, or in maybe another business process has a business outcome they want to enable with AI to create and become this agentic organization, this agentic enterprise. So if you'd like to dig in more, I believe we actually have some extra time built into this talk, and we can take some questions off stage, or you can come visit our booth out in the expo hall again. 802, come get some poolside swag and talk to us about how we could help out your organization. Thanks.